Hi everybody, good morning, afternoon, or whatever time it is. Hope you're all well. Hope you're enjoying the last week of term slash Christmas, just in general, to be honest. Um, so this little lesson here, this video lesson, is all about logarithms, and it's just the introductory stuff to begin with, just what a logarithm is and how you can use them to solve problems involving powers, right? There's two exercises that we'll look at in the notes, and we'd also like you to do a little sort of quiz on Microsoft Forms at the end, just so we can check how you've understood it, if that seems okay. It doesn't all have to be done in your regular lesson slot. You can do it any time before your next lesson, all right? So as long as you're up to speed before that first week in January, should all be good. Right, let's talk about logarithms then. So here we've got a few questions where the power is unknown. I'm going to pull them up on the screen now. So we've got 3 to the power of something is 9, 2 to the power of something is 32, and 10 to the power of something is 1,000. So take a minute or so, see if you can figure out what those missing unknowns are. And if you pause the video here, I'm going to pull up the answers in about 3 to 4 seconds. Okay, that is it, and let's go, let's have a look. So what you should have is 3 squared, 3 to the power of 2 is 9, 2 to the power of 5 is 32, and 10 to the power of 3 is 1,000. And you might not have had like a particular strategy for it, even if you did get all 3. Some of it might have just come from experience, like, oh yeah, I just know 3 squared is 9 because I know my square numbers. 2 to the power of 5, well, I guess you could have just said, oh, I'm going to keep times in by 2, 2, 4, 8, 16, 30. Oh, look, I'm here, 5, until I get there. And powers of 10 as well. I mean, you can just count how many zeros are there. So sometimes there's patterns and strategies you can use. But sometimes we're going to run into some difficulties. So, for example, if I flick onto the next slide here, we've got a problem where we have a power of 2. It's 2048, and it is a whole power of 2. Like if you keep doubling 2, 4, 8, 16, 32, you will eventually get to 2048. But it's going to take some time if we use that strategy. I suppose alternatively we could use our calculators and kind of brute force or trial and error it, like, you know, oh, let's try 2 to the 10. Is that anywhere near? Oh, it's not enough. Let's try the next number up. However, there is a better way of doing it, and this is where logarithms come in. Okay, so we're introducing logarithms now, and what they allow us to do is rearrange problems that involve powers. So let's have a look at a few examples here. So earlier we had the statement 2 to the 5 is 32. Right? We can write that as log base 2 of 32 is 5. So notice the positions of all the numbers here, right? Notice where the 32's gone. And notice again the position of the 5. Okay. The main thing to notice is just the consistency, that always happens with these cases. So these numbers that I've written in yellow, they are sometimes referred to as the base. Right? And you can see that when you put it into logarithmic form, they've always ended up down here as a little sort of subscript. Similarly, the numbers that used to be on the right side have ended up within the logarithm here. And then finally, the numbers that were powers before have ended up on the right hand side. What I'll do, I'll cut to a clip of me going through it on the calculator so you know where the log button is, and then we'll segue back to this PowerPoint. So just a little side note, by the way, obviously we want to be able to type these in on our calculator, so the log button, the one that you need, is just here. It's 2 buttons down from the menu. Press this. The number at the bottom is your base, so let's go for 2. And the number in the brackets is sort of your power of 2, I suppose. So let's say we had something like 128. So what your calculator is going to do here is it's going to say, okay, 128 is a power of 2. What power is it? 2 to the power of something gives me 128. What is that power? And in this instance, it works out as 7. So that's what logarithms do. Pretty handy, right? So let's go back to the PowerPoint and let's have a look at the problem coming up. What we do is we can rearrange that using the logarithm, and I'm just going to write it on the side here. So it's going to be log base 2 of 2048, and if I type that in on the calculator, I'll be able to get the n value. Right, so feel free to try and test it out yourselves on your calculator if it's handy. But what should happen here is we should get the value 11 out, which tells us that 2 to the 11 is going to give us 2048. Now, in the notes, there's a little exercise to try. It's mostly just changing between exponential form and logarithmic form, or index form and logarithmic form. It shouldn't take you more than about 10 minutes, 15 minutes. There's answers at the end of the chapter if you have your booklet handy. Alternatively, if you use the PowerPoint or just use this video, there's going to be some answers in a few seconds. I'm going to move them on in about 3, 2, let's go. Okay, cool. Here's some answers. That's handy, isn't it? Wonderful. Now, something else that we can do with logarithms is we can solve problems which don't have integer solutions. So for example, this one here, 3 to the power of something is 20. Something you probably realize is that's not a whole power of 3. We do have 3 squared, which is 9, and we have 3 cubed, which is 27. So 20 looks like it's somewhere in between. So if I was to sort of hazard a guess here, I would say that the value of n is probably somewhere between 2 and 3. In terms of actually working it out, we would do exactly as we were doing before. We just work out a logarithm, log base 3 of 20, and we get a value out. In this instance, it works out as about 2.73, and that's our answer. Okay, so here's 3 different examples I'm going to try. They're on page 127, I think. That's what it is in my booklet right now anyway. If it's not exactly the same, it's only about 3 or 4 pages into your notes. You'll be all right. So the examples I've got, the first one is as follows. 2 to the power of something is 1,000. And it says to give n to 2 decimal places, which indicates that it's not going to be like a nice whole number here. So let's grab the calculator and let's type in what it's equivalent to. So 2 to the power of n is 1,000, can be written as log base 2 of 1,000 equals n. So let's type that in, log base 2 of 1,000. Lovely. Okay, 9.9, let's round it up to 9.97 there. Cool. That was all right, wasn't it? So this next one, slightly different because we've got a power this time of y plus 1. So not quite as simple as just rearranging and that's it. We'll have to do a little tiny bit more. So let's write it down originally. Y to the power of y, 4 to the power of y plus 1 is 100. That's going to write as, when I change it, log base 4 of 100 equals y plus 1. Let's figure out what this bit is first. So let's get rid of a 0 there. Let's change that to a 4. Okay, so this works out as 3.32. So I'm going to change this to 3.32. And now I've effectively got just a linear equation, an equation where I can say, okay, I'll take this 1 over the other side, and it'll become a -1. And then I'll get a value of y, which is around about 2.32. Cool. Oops, where have I gone? Jumped. Okay, we're back. So this last one, the wording's a bit different this time. It mentions that we're finding an exact value of x, which indicates to me that it might not be a decimal value. This might be like a whole number or like a fraction or something. Let's have a look at the problem. It's 2 to the power of 2x plus 3, and it's equal to 32. So once again, I'm going to write it down as it is, and then I'm going to write it with logarithms. So the base is going to be down here, the 32 is here, and then the 2x plus 3 over on the right hand side. Now I'm pretty sure log of 32, log 2 of 32 is 5. Yeah, it's 5. So once again, I've got a linear equation, something that I can solve. Just a little bit of rearranging. Let's take the 3 over. Then finally, this is going to work out as x is 1. Yeah, nice, cool. Okay, so hopefully that seems all right, folks. This little exercise here, exercise 1b, it's on page 128, and there's answers at the end of the chapter if you need to check anything over. We'd expect this would take you around 20 to 25 minutes. Focus mostly on question 1 and question 2. Didn't mean to draw on it there. Question 1 and 2. Question 3 you can think of a bit more as an extension. Right? We won't see this too much, but it's useful to be able to rearrange statements like that. Once you've done that, there is a little activity that we've made on Microsoft Forms. So if you go back on Teams, the very last little link there, it's just a little quiz essentially, and it'll give us an idea of how well you've understood it, and number 2, who's actually tried to do the work. So please have a go at that. It won't take you more than about 5-10 minutes. And yeah, it should summarize what you've covered today quite nicely. Cheers, guys. Hope you have a nice Christmas, and take care of yourselves. See you in January.